What's that? Well, I think, the first time I did I have it on that table as well?
Well, it
I
wasn't,
had it on this table,
The second time I did it was on this table, wasn't it?
Both times. I think.
both times,
Oh,
and then you
I don't
moved
know
it
why
back here.
it seems too close now when it's on that table. Maybe the tables are back. All right, so let's put up to these. Speaker is no good. You can tell I get nervous when that thing is on for some reason. I gotta get used to that. Remember those 6 trig functions in the unit circle. Cosine is, and I always leave this part off, but you can put theta or t. Cosine is always what? What letter? X, yes. Sine is always what letter? Y. Tangent is always what? Y over x. I really, really need you to remember that as sine theta over cosine theta. Because after this chapter, we're not going to be using the y's and the x's anymore. You have to remember it, but we're not going to be using them. And we're going to be using the sine over the cosine, which is y over x. Okay? And the opposite of sine, I'm going to put it right here, is cosecant. Because we want to remember that s right in the middle. Cosecant is what? 1 over what? 1 over y, which is, again, I need you to start remembering it as 1 over sine theta. And then 1 over y. Because we're not always going to be in the unit circle. We're going to move on. Okay, if cosecant is 1 over sine, what is secant? 1 over cosine, yes. And cotangent is the opposite of tangent, and sometimes I think cotangent is easier to remember, because it's co and co, cosine over sine. Or just flip the tangent over. That's if it were in the unit circle, okay? That's a review. I'm not going to spend any time on those. We did a whole worksheet on those, so I think you should be okay with those. Any questions on them? Okay, now we're going to move out of the unit circle. So when we're not in the unit circle, this method will work in the unit circle as well. I mean, you could just do this every time, but it's a lot longer. That's why I would rather you do the shorter way for the unit circle. There are a couple of different ways to teach this. The way that I'm going to teach you is to draw a picture, because later on in this class we have to use that way anyways. You know, we could go back to sine squared plus cosine squared equals 1, like we did with that very first assignment we had in here, but I'm not going to teach it that way. So here are, this is what I'm going to say, draw a picture. And this is what this lesson is about today, is drawing that picture. So you might have problems that are in the unit circle, but we're still gonna do it this way. Okay, we're still gonna, they aren't gonna be your known ones, I guess. So for example, if I have -3/5 and 4/5. Can you tell what quadrant it's in? Okay, because remember the signage. Positive, positive when you do ordered pairs. This is negative. This is negative. Or like some people said, they like to do this. And somebody just tell me that today. Okay, so if I have a negative, positive, and I'm graphing that, that's in quadrant 2. The quadrants go like this. Just as a review. Okay, whenever you draw a picture, depending which quadrant you're in, you're always going to draw that triangle with the x-axis, like this. If you're in quadrant 2, that's where it's going to be drawn. I can give you another one. If you're in quadrant 1, and you're going to be drawn right here. If you're in quadrant 3, then it's going to be underneath like this. And theta or t is right in there. There's theta. There's theta. And quadrant 4. Right there. So we just have to make sure we get that triangle drawn in the correct quadrant every time we draw, and it's always drawn with the x-axis. And we use SOHCAHTOA from there on out then. You just have to keep your work organized and neat. Give yourself a lot of working room, because there's a lot of things you have to do. Sometimes you have to use the Pythagorean theorem. Okay, can I erase this? I'm going to rewrite this ordered pair. Was it -3/5, 4/5? Is that what it was? Sometimes they'll tell you what quadrant it's in. Somehow you have to figure out what quadrant it's in. Sometimes they'll just give you the signs, but you have to know what quadrant it's in. I always write SOHCAHTOA because it's a visual for me. Kind of takes the thinking out of it then. And we already discussed that this was in quadrant 2. Theta or t is right in there. Okay. Now I actually know that this is in the unit circle, because if I do -3/5 squared plus 4/5 squared, do I get 1? 25 plus 16 over 25? That's 25 over 25, right? So I can kind of look at them myself and know what kind of circle I'm dealing with. If it works in x squared plus y squared equals 1, or cosine squared theta plus sine squared theta equals 1. Anyways, we're going to take the x. Remember, this is cosine, this is sine. So cosine is adjacent over hypotenuse. So here's your reference angle. Adjacent is down here. So with the value of this fraction being negative, that negative could be on the 3 or, I mean, you don't know if the negative is in the top or the bottom or the middle, right? Because every time we have a negative in the bottom, we move it to the top. But because this is adjacent over hypotenuse, I know that negative is going to go here and 5 is going to go here. It will never, the hypotenuse itself will never be negative. Just your x or your y might be negative. And you can tell already what kind of triangle that is. What is it? 3, 4, 5. And that holds with sine being 4/5. The sine of theta is 4 over 5. And once you have your triangle labeled, then you can find the other 6 trig functions, all of them. So do you have any questions on that much? Okay, so let's go with cosine theta. We already know is negative 3 over 5. Sine theta, we already know is 4 over 5. Secant theta is your cosine flipped over. Or go back up to flipping these two around. It's the opposite of that. Keep the negative in the top. Middle or the top. Don't put the negative in the bottom. Cosecant is what flipped over? Sine flipped over, yes. Am I going too fast? So flip the sine over 5/4, or it's the opposite of this. Tangent we didn't do yet. Tangent is opposite over adjacent. Opposite is 4 over negative 3. Am I going to leave the negative in the bottom? No, it's negative 4/3. And then cotangent is that flipped over. Leave the negative in the top. Now, because I knew that that worked in this equation, did I really need to draw the picture? I could have just used the fact that this is x, this is y, this is cosine, this is sine. Okay? So it works either way on this problem. I'm going to give you one where you have to draw the picture. Okay? But do you have any questions or clarifications? And if you ever do have questions, if you ever want me to send you the video, I certainly can, but I don't have to. You can go to YouTube and just search. It's on the YouTube. It's on YouTube. Just search Treg and then Tracy Jaworski, my name, and it should come up. Okay. We don't get a link because you have to have so many followers to get a link. So, okay, let's try. Secant of t equals 2